Welcome back to the Deep Dive. Today we're getting into something really fascinating, not just reading about algorithmic music, but actually decoding, well, basically an entire orchestra that builds itself live.
Yeah, it's quite something. Note by calculated note.
Exactly. Our mission here is to look under the hood of what our source material calls the deterministic pianist.
That's right. And for you, we've really dug into this custom composition engine. It's built inside Pdida, Pd, that visual programming environment.
Right.
And critically, it uses the Pdida library. That's important because Pdida is designed for, well, high performance, real-time sound generation, mission-critical stuff.
So this isn't just about modeling music in theory. This is a live performance patch generating sound as we speak, essentially.
It's a living system, absolutely.
And this really flips the script, doesn't it, on what most people think algorithmic music is.
How so?
Well, you usually think of randomness, maybe chaotic systems generating unexpected stuff. But the deterministic pianist, it works on a completely different principle.
Completely different.
Every single rhythm, every pitch, harmonic change, it's all strictly calculated. Defined mathematical relationships are driving everything.
And that is the absolute core insight here. The real art, you could argue, isn't just what the machine plays, but it's in the design of those underlying mathematical rules.
Okay.
If you tune those rules just right, the system has to generate interesting, complex music. There's no reliance on chance. It's this closed, self-referencing musical ecosystem.
Okay, let's unpack this engine then. Starting right at the foundation, the rhythm. The source calls this layer groovy, catchy name.
Oh, yeah.
And it begins with a kind of dual clock system.
Right. The initial timing pulse comes from a specific module.
Okay.
Pulsa plus 475. Now, this isn't just your standard metronome click like a square wave. It generates what's called a modulated pulsation. Those numbers, 4 and 7, they suggest a ratio, sure, but the really key parameter is that third one, the 5.
Okay, the 5, what does that do?
That defines an internal cycle length. And it's that cycle that creates the modulation, the subtle variation in the pulse itself.
So it's not just on-off.
Yeah.
And then there's filtering involved, too, using threshold logic.
Exactly. That filtering takes the modulated signal and deliberately creates this inherent unevenness. A kind of, well, like a perpetual musical stumble or push-pull.
Right from the start. So you're engineering the groove, basically.
You are. It sounds almost humanly irregular, you know, but it's perfectly mathematical underneath.
Okay, so this groovy pulsed signal, where does it go next?
It feeds into the accumula 0.45 module. This one's called the Rhythmic Distribution module. Its job is to take that initial complex pulse and divide it up between the different melodic voices.
Right, and the notes mentioned this module uses Bresenham logic. Now, I know Bresenham from like old school computer graphics, drawing smooth lines on pixel grids.
That's the one.
How do we get from drawing lines to generating musical tension? That seems like a jump.
It does, but think about what Bresenham does. It minimizes error when plotting points along a line on a grid. In musical timing, distributing rhythmic hits over time, minimizing error actually means maximizing the delay or the stagger between hits.
Ah, I see. So it's trying to distribute the hits from pulsa plus as evenly as possible between, say, two outputs.
Exactly. And that parameter, 0.4555, is crucial. It's close to $0.55, which would be a perfect split.
But it's not quite $C.55.
Right. So the system is always trying to hit the pulse nearly perfectly in the middle for the distribution, but because it's Sarah-Palligan 455 cents and it's using Bresenham's logic to minimize the distribution error over time, it consistently creates this tiny calculated delay, a stagger.
Okay, so the math itself forces one voice to always be slightly behind the other, relative to that initial pulse, and creates that push and pull feel.
Precisely. That specific value, Sarah 555 cents, generates a very particular, very tense polyrhythm. The system then splits this staggered timing between its two hands, as the source calls them.
Like a pianist.
Kind of. The right hand, motivo 1, gets the main pulse. It's aperiodic, remember, because of pulsa plus for the main melody. And the left hand, motivo 2, gets the remaining slightly delayed timing for its counter melody.
So they're locked into this perpetual calculated rhythmic tension.
Locked in. Guarantees they won't just fall into simple, boring synchronization.
That is clever. But does that perpetual tension ever, resolve rhythmically? Or does the listener just get used to it? Constant tension can be tiring.
That's a good point. The resolution tends to come more from the harmony, the long-term shifts, which we'll definitely get to. But yeah, rhythmically, the tension is pretty core to the system's identity.
Okay. So let's move on from rhythm then.
Yeah.
Section 2.
Yeah.
Melodic execution. We've got the timing, now we need the notes themselves.
Right, and those are generated by two parallel instances of another module, motivo.
Motivo.
These are described as tension-based melodic generators, and they use something called a directional walk.
Directional walk, so not just a random walk where the pitch could jump anywhere.
Exactly. Unlike a simple random walk, these motivo modules have a built-in tendency, a direction.
And the parameters mentioned are 40 $4 4 days. That sounds like strong opposing forces.
Very much so. One motivo module is set up with parameter 4, giving it a strong inclination to move upwards, to ascend. The other one, with 4 sorlars, is inclined strongly downwards, to descend.
So this maintains that opposition we saw in the rhythm section.
It does. It ensures the melody flows, it avoids just repeating simple patterns, and it keeps that structured opposition going. The music isn't just meandering aimlessly, it feels like it's climbing and falling with, well, a calculated purpose.
Okay, makes sense. Now there's another interesting module mentioned for filling in the gaps. Fill 1, 2, 3, the Contextual Harmonization module.
Oh yes, Phil. This is a really neat part of the system, adding density. It doesn't generate the main melody itself, it operates only on the right-hand line, the motivo 1 output.
And what triggers it?
It basically listens for the main melody to take a rhythmic breath, a longer note or maybe a pause, a gap.
Okay, so when motivo 1 leaves some rhythmic space, fill jumps in. But how does it decide what notes to play? Is it just harmonizing randomly?
No, it's still deterministic. It receives the current scale degree that the main melody note represents.
Scale degree, right.
And then, using the regular unstaggered pulse from the original pulsa plus B.
Using the original pulse?
Yes, the faster underlying pulse. It uses that timing to strategically add fixed intervals relative to the main note's degree. The parameters, $1, 2, manic 3, 3, define those intervals. Typically, they correspond to adding thirds and fifths, maybe octaves, depending on the setup.
So if the main melody, motivo 1, plays a long C note, Phil might quickly interject an E or a G using that faster pulse to flesh out the harmony.
Exactly that. It fills the space contextually, it provides density, harmonic context, but it never clashes with the primary melodic idea being generated by motivo. It's like an automated harmonizer, but strictly rule-based.
Very efficient. Makes the texture sound much richer than just 2 lines.
Without needing the composer to write out every single little passing note, the system handles it.
Okay, this logically leads us into section 3, the harmonic brain. We've got these intense moment-to-moment calculations for rhythm and melody, but how does the whole thing stay coherent harmonically over longer periods?
That's where MAPA plus 7/12 comes in. This is described as the harmonic brain of the system. All the melodic activity from both motive modules converges here.
And its first job is quantization.
Crucial first job, yes.
Wow.
Pitch quantization. Whatever complex pitches the motivo modules might generate through their directional walks, MAPA plus snaps them firmly onto a defined scale structure. The parameters 7 and 12 tell it to use a 7-note scale within the 12 semitones of the octave.
Right, so it keeps everything sounding in key, more or less, prevents the tension from just becoming noise.
Precisely. It imposes harmonic order, but the real secret to the long-form structure, the evolving harmony, lies elsewhere.
Okay.
The overall tonality of the system, the key center, it's not fixed. It gets modulated over time.
Okay.
By these interconnected, very long cycle generators called circula. These are the key to that slow, evolving transformation of the entire musical landscape.
Circula. Let's break down those cycles then. The parameters seem key. The first one mentioned is circula 3, 2, 7.
Right. The numbers here are critical. $3, $2, and $70. They define a specific mapping or movement pattern. This generator runs on a very slow cycle, and its job is to shift the active scale degree reference within the MAPA plus module.
So it's changing which note of the 7-note scale feels like home.
Essentially, yes. By cycling through the scale degrees in steps that often correspond musically to intervals like thirds, it makes the music's harmonic center slowly shift. It gives this subtle, warm, evolving harmonic color over time. It's like modulating between closely related keys, but very gradually.
Okay, modulation by thirds. And the second circular module, even longer cycle, it says circular 3, 7, 12.
This one's even more fundamental. The parameters $3 and $7 and $12 relate to the 12 semitones. This module modulates the entire system's root tonality. It shifts the harmonic bass, often by intervals corresponding to fifths.
Like moving around the circle of fifths.
Exactly like that, but in a slow deterministic cycle defined by those input numbers. Since moving by fifths, often 7 semitones, creates strong structural shifts in Western harmony, This cycle ensures that over, maybe several minutes, the entire musical world the pianist inhabits can completely transform.
Wow, so you have these nested cycles, fast, tense, rhythmic calculations from accumula motivo, medium-term harmonic filling from fill, and then these really long mathematical cycles from circula underneath it all, guiding the overall harmonic journey.
It creates this amazing architecture where the musical narrative feels predetermined by the math, yet it's constantly slowly evolving.
Which brings us right to section 4, the performer's role. Because if the math is so detailed, if the rules are so complete, well, what's left for the human to do? Does perfect math remove the chance for, happy accidents?
That is a really profound question, isn't it? The source talks about intervention a caldo, literally hot intervention, live intervention. The human performer doesn't play the notes directly. Instead, they act more like a system conductor, maybe, or a gardener tending the system. They guide the machine's aesthetic direction while it's running.
So what can they actually change?
Quite a lot, actually. They can tweak the rhythm on the fly, change the pulse ratio in pulsa, plus maybe alter that critical points of 455 value and accumula to make the polyrhythm more or less tense. They can even mess with the motivo modules, change the directional parameters, maybe flip that ascending line into a sudden descent, or vice versa.
So the performer becomes the agent of disruption, or maybe productive change, injecting those happy accidents by changing the rules, not the notes.
That's a great way to put it. They're manipulating the parameters that define the system's behavior, but the most powerful intervention, the one noted as having the biggest impact, is inserting a new seed.
A new seed. What does that actually feel like in performance? Is it a sudden jolt or more controlled?
Well, because the entire engine is deterministic, that initial seed value defines everything the system's current state and its entire future path, given the rules.
Right.
So when the performer decides to input a new seed number, it's a really dramatic act. It's pure aesthetic judgment in the moment.
And the effect?
It instantly resets the whole deterministic state. It triggers a completely new, unique evolutionary trajectory for both the melody and the rhythm. It feels like an immediate, powerful shift, like a whole new piece is beginning, using the same underlying rules, but starting from a different point of mathematical origin.
So the performance becomes about the human deciding, okay, this particular mathematical unfolding has run its aesthetic course. Time for a jump. It really changes the idea of composition.
It absolutely does. The performance is about applying that real-time aesthetic judgment, intervening only when the system needs that kind of drastic reset to maintain musical interest or explore a new path.
Okay, let's go to the final output then. Section 5. Sound quality. We have all this intricate math, these interacting modules. But if it sounds, well, mechanical, the whole artistic point is kind of lost, isn't it?
Completely lost. Doesn't matter how clever the maths is if the sound isn't compelling.
So how does this system ensure the music actually sounds good, sounds expressive?
Well, the basic sound source itself is mentioned as a physical model called casefa that provides a specific timbre, likely something plucked or struck given the pianist's name. But the really crucial part for expression is the dynamics, the volume control.
Right.
That's handled by Dynamica 2.65, 0.35. And this isn't just a simple volume knob, it's described as a sophisticated LFO for expression.
An LFO. Usually that makes me think of a predictable wobble, maybe a tremolo effect.
Yeah.
How does this avoid sounding, rigid or robotic?
Good question. It achieves what the source calls a continuous breath. Instead of a standard linear attack-release envelope, which can make notes sound very sharp, very on-off, and machine-like, this Dynamica module uses its parameters, bools and 65 cents, to shape the volume using a nonlinear cyclic curve.
Nonlinear. So the shape of the volume change isn't just a straight line up and down.
Exactly. It's constantly reshaping that curve, cycle by cycle. It avoids those rigid, sharp attacks and decays. It gives the notes a smoother contour.
So by using this nonlinear LFO, it injects this layer of something more organic, almost like a vocal quality into the sound.
That's the idea. It aims to counter the the potential rigidity of all that deterministic math driving the notes and rhythms.
It gives the music dynamic nuance, makes it breathe, mimicking perhaps what a human performer does instinctively.
Precisely. It makes the algorithmic result much more musically compelling, hopefully avoiding that trap of sounding sterile or lifeless. It's really the final, crucial step in bridging that gap between the perfect calculation and something that feels like genuine artistic expression.
What an absolutely fascinating journey through this system. We started with pure data, this visual environment. We saw the tense, staggered polyrhythm emerge from accumula using Bresenham logic.
Dividing up that initial groovy pulse from pulsa plus.
Right. Then we saw Phil stepping in, adding that contextual harmonic richness whenever the main melody took a break.
Filling the gaps intelligently.
And underpinning it all, those slow, almost inevitable harmonic transformations guided by the long mathematical cycles of the circular modules.
Yeah, shifting the scale degrees and the overall tonality over minutes. It's composition designed entirely through this web of interconnected mathematical structures.
Incredible. And that brings us to a really interesting final thought, building on what you said about human intervention.
Okay.
Well, you posed this idea earlier. If the composer's role shifts so dramatically from writing notes to defining these, let's say, perfect mathematical rules, and the human intervention during performance is limited to tweaking those rules, or just inputting a new seed, choosing a new starting point for the math.
Right, a sort of architectural starting point.
What does that actually imply about how we define composition? Is it still composition in the traditional sense? Or is it more like, gardening in the digital age?
Yeah.
Cultivating these complex systems?
That's the provocative question, isn't it? Where does deterministic rulemaking end and creative composition begin? What is the limit of determinism when it comes to generating something we perceive as truly creative or artistic? Something for you, the listener, to definitely chew on as you reflect on this idea of the deterministic pianist.